Kakkana. This video is to discuss my final project, case study on meteorological data. Data is everywhere and it is being produced in various scientific, educational and societal organizations for research and analysis. Analysis of data used to have many hurdles before because of size barriers. Big data tools solved this problem and made researchers to analyze data easily and more accurately. My project is to analyze one of such meteorological data using big data tools. So I searched for data in many web pages and I came across this National Oceanic and Atmosphere Administration. It is being maintained by United States Department of Commerce and they focuses on conditions of the ocean and atmosphere. They are responsible for monitoring and observing Earth systems with instruments and data collection networks. I looked into many datasets like temperature rise, precipitation, sea level rise, etc., and finally found storm events data being well organized, documented, and robust. So the data is available in this website. In this website. So I downloaded data from 2002 till 2013, and the data looks like this. So it consists of begin day, end day, state, month, and storm type, and many more details. Apache Spark. It's a open source cluster computing framework. It works pretty much faster than Hadoop. Code is very less and pretty much straightforward when compared to Hadoop. This is sort of difference between Spark and Hadoop, in which you could find the data being stored in cache, which is a main thing that helps Spark to do things pretty much fast. D3JS is a JavaScript library for producing dynamic interactive data visualization in web browsers. So my goal was to uh, use this storm events data and to do big data analysis through Spark and use D3JS to visualize the results as graphs. So I started my Spark with this, with this code with 4 threads, and so once I had my CSV file parsed, then I dropped the header so that it doesn't interfere in the results. And I took measurements of 5 different types. One is number of storms that occurred by state from 2002 till 2013, number of storms that occurred by month, number of storms that occurred by storm type, number of storms that occurred by state and particular month. This is sort of a combination between state and month. Number of storms that occurred in particular month and has a particular type. This is again a combination. Uh, so this is the graphical representation of number of storms occurred by state, and this is a few lines of output. If you see Texas being that holds most of the storms. This is a graphical representation of number of storms occurred by month. This is a few lines of the output, and you could see July being that has many number of storms. This is a graphical representation of number of storms occurred by type. Thunderstorm wind has most number of storms when compared to others here. Now it's a combination. To use this combination, I used buckets. I created buckets that hold data in various ranges, and data would be revealed through mouse over. This is one of the example in which it shows July flash flood here, June flash flood here, and this is the data that is available through Spark. Uh, this is another combination of number of storms that occurred by state in particular month. Even here I used buckets to held data at various ranges. This is one of the examples. Yeah, yeah, thanks.